2013, I made a video. I believe it was toward close to the end of the summer. I believe sometime in August of 2013. I mentioned how I was going to make a video about this burner, which was new at the time, but since then it's now been connected to this boiler for 3 years. And this will actually be my final video that I do on this boiler and in this boiler room. Why? Because I am switching occupations. I'm landing a different line of work and I'm moving on from this field. Now, just for the record, I've had some people come at me a couple of years back and said, "You're a boiler man." No, not at all. As a matter of fact, I spend the least amount of my time in a day in this room. The only time I really come in here is usually in the morning just to check it. And as long as it's running, there's really nothing for me to do. So I'm in and out of here in about less than 2 to 3 minutes, or probably not even a minute most of the time. So just to clarify those little rumors that, "Oh, you work in the boiler room." Of course, we know the group of people who were saying this, so just to prove them wrong. But anyhow, that's beside the point. However, I just wanted to make a brief video on this burner. Now, this is not the same burner that I had on this boiler years ago. The last burner that was on here was a D-series dual fuel. It can burn all grades of oil from 2 to 4 to number 6 oil, and it can also burn gas. And it's the same exact thing with this burner here. This burner can run 2, 4, and 6 oil, even though 4 and 2 oil is not permitted to be burned in the city of New York any longer. That's another reason why we swapped out the burner, because we went to gas. So this has a dual combination of gas and 2 oil. So let me just briefly run down I'm gonna start my way from the top of the boiler and I'm gonna work my way back down. Okay, so up here, that big pipe in the back, well, let me get another look at it. I'll start right there. You have your steam header. That's a steam header, and it runs up into the steam main. It branches off and goes to the north end of the building and the south end of the building. The main runs from about, I believe it starts off at about 8 inches. It gets reduced down to 6, goes back into the 8-inch over here, and then it goes through the, I believe that's 6. It could be 8, but it gets reduced down to 6, and then it's down to 4. So here you have your steam header. Oh, and just for the record, this manhole has been replaced because it had started leaking the winter of 2015. So we since then had that replaced, had new gasket replaced on it and everything. Okay, of course you know what this is. I'll run down this briefly. These are your domestic hot water supply, your cold water inlet. This is your return for the hot water circulation, which ties into this circulator pump right here. I have a video that I tied up into this where I installed this circulator last year, early 2015. And then you have your hot water supply right here. Of course, the valves are in shitty condition. And I've been trying to get these people to replace this stuff and upgrade it to ball valves, but that's a whole nother story. I'm not going to get into that one. So let's make our way to the top of the boiler now. So here we have the pressure gauge. Usually on commercial grade boilers that do big buildings, I haven't seen the steam pressure exceed any higher than 7 psi. This building, the max pressure permitted is 5 pounds of pressure. That's what I have it set to. That's for the cutout. The cutout, I believe, is about 4 to 3.5 psi. Pressure control that you have right over here, right next to the pressure gauge, that's for the modulator. Now, on the modulator, that works on the burner. As I've demonstrated it years ago, back in 2012. As you see, I got the switch on auto. You go to manual, auto. I keep it on auto in the wintertime. Auto, that activates the modulator. So the only time this modulator becomes active or that pressure control becomes in use is when you're running a steam cycle. So basically, if you're running a steam cycle, instead of your burner bringing it up to 5 psi, what it'll do, it'll hold the pressure just a little lower, or maybe exactly at, but in this case, I have it set at 3 psi. So instead of it going all the way up to 5 psi, the burner will hold the pressure at 3 psi, and these linkages here will drop down. It'll cut back on the air from the blower motor. It will cut back on the gas or the oil coming in from the from these tubes over here, and it'll just simply reduce, it'll back off on the flame. The flame will back off and you'll have a smaller flame in there and just pretty much hold it, and it'll increase it or decrease it as need be. The next pressure troll on here, one of these is obsolete. One of these used to be connected to the old hamster wheel timer, heat timer system that we used to have. I do believe, let me see, I can't see if I zoom in. I believe that might be it. Let me see this one over here. No, I think this is it right here. You see, no, that might be the manual. That might be the manual. I forgot which one it is. But one of them used to tie into the heat timer that we had for when we had the older heat timer system that had the hamster wheel. And pretty much when the boiler would get to about 2.5 or 3 psi, it would send the, what it would do, that mercury ball would drop, and it would make the contact, and it would pretty much let the timer know that the heat circulation has been established. I believe it is this one that is set. This is the pressure cut in and cut out. Okay, so yeah, this is for the pressure cut in and cut out. The pressure cut in is at 3 psi, and the cutout, as you see, directly at 5 psi. Even though these gauges, sometimes they can fool you, so you can't necessarily know off of that. But this is what will cut the boiler off if you have the burner on manual. It'll run the 5 pounds of steam pressure, and your burner will shut down once that mercury ball makes a connection. So that's set for 5 psi. So this one here is now obsolete. Well, it's been obsolete since 2007 when we installed the platinum heat timer system, because we run off of a sensor which is tied into I hooked it up to a steam main because to get a little more of an accurate reading. Now, as far as this one is concerned, this is your manual pressure troll, meaning that if your boiler, if any of these fail to shut down this burner or to reduce the flame, what this will do, the pressure will build up, and this will pretty much cut out. It might be set to 10 or 15 psi. I believe they normally set to 15 psi. And if it goes any higher than that, what will happen is this pressure troll is going to shut down the entire operation. And pretty much you're not going to be able to fire the boiler up unless you actually climb up here and reset that switch, that little button that you see right there, little red button. Now here's one thing that I've noticed. I can actually set that or trigger that switch to go off. In certain cases, I've done this once or twice with this boiler. I've known other supers that have done the same shit, and it's just a matter of being clumsy. If you don't have an automatic water feed, or for whatever reason, let's say you're filling it up manually and you just want to rush because the automatic water feed might take too long, so you know what the hell with it, I'm just gonna throw it on and just let it fill with water. You walk away, you look around the boiler room, and you get distracted. Before you know it, you make your way out through the door there. You get a phone call from a resident, and they say, I got water coming out of my radiators. I don't know what the hell's going on. And you're thinking, well, there's not even heat on in the building. Why the hell is there water coming out of the radiator? Well, you know what you did was you forgot to shut off your manual water supply. So now what happens once that gets, once the lines and the steam mains get filled up, what happens is you have, instead of PSI, you have LBS, weight, sitting inside of those pipelines, because you know water has weight to it. And pretty much what that's gonna do is it's gonna exceed the pressure limit, and it's gonna cause this switch here to cut right out. So when you drain the boiler down, a lot of people don't even think of this. They'll drain it out through your either your bleeder valve, which will shut off, which will pretty much shut the burner down once it reaches low water, or you can bleed it through the back. And pretty much once you get it back down to water level, you turn the boiler back on the boiler doesn't come on. You're wondering, okay, why the hell isn't the boiler coming on? You tried everything. Everything is set. You checked your fuses. Everything is good. Or you check the circuit breaker. Throw the damn thing on manual to see what the hell happens. You look inside of here. All right, let me reset a bunch of things in here. The shit still don't come on. If that happens, well, you know the reason why it didn't come on is because you have to go get you a ladder, climb up here, and press that button. That is the only way you're gonna get the burner to come back on. Now, aside from that, okay, so I just did a rundown by the pressure trolls and pressure gauges. Now you have your water supply. This is for the manual water supply, and this is for your automatic water supply. You have the automatic water feed, which has the low water cutoff built into it. The water's a little rusty, don't mind that. I just drained it out, so it'll come up a little rusty, but you see it's tied right into this, and it goes right into this backflow preventer valve. Basically meaning if any water comes back from the boiler, of course you have your check valve as another backup as well. So you have the check valve, and then you have your backflow preventer valve, meaning that if any water for whatever reason pushes up through here and tries to make its way back into the main water supply, instead of it going into the line, it will come out through here. I don't know if I got it in a video a little while ago, but there was water actually coming out of it. Let me see something, see if I can get this to activate. Nope. A little something came out of there. So of course you can hear the automatic water feed activating when I flush it down. Now let me just say something here, because one thing I don't like, and this is the one thing that has irked my nerves about whoever the hell put these boiler systems in, is they did a fucked up job. And what I mean is this right here. You're never supposed to tie in your water supply directly into your boiler. This is one of the worst connections that you can ever find. The reason why this is, and even though this is a steel boiler, you still don't want to take chances like this, because what you're doing is you're introducing fresh cold water directly into your boiler. So if you got long runs and you're doing a steam cycle, this level is going to start to drop, and that water feed is going to start to supply this boiler water. And once you start putting in cold water into your water supply or directly into your boiler, what it does is it causes the metal to contract, because we know that metal expands and contracts according to temperature. Heat will cause it to expand, and cold will cause it to contract. So essentially what you'll have is a temperature shock that can take place in your boiler, and it could cause you a lot of unnecessary problems. The way this is supposed to be done is actually supposed to be tied into the return line, or tied in somewhere right around the Hartford loop. The reason why it's supposed to be tied, and this is the Hartford loop right here for those who don't know. This red line that you see goes right into the steam header, and it goes right back into the return line. It's no different than the Hartford loop I showed on my boiler that I have in my apartment. The reason why it's supposed to get tied into the Hartford loop or into the return line is because as that boiler starts to feed with water, there's constantly hot water coming back down through this. So when the water comes through here, it's being saturated, it's being mixed in, and it's being heated. So it's being reheated as it comes back into here, meaning by the time it makes its way back into the boiler, it'll be at return line temperature, meaning you're not gonna have a temperature shock going right into your boiler. So whoever the hell did this did a stupid ass idea. They just didn't know what the hell they were doing. Now, this thing looks raggedy as hell, and for a reason, because number one, it is not my job to fix it. So when it comes down to all of these idiots that say, oh, you're a boiler man and you work in a boiler room. No, dude, I don't fix fucking boilers. Not that I can, but that's not my job description. So I do what is supposed to be done, and I report any issues on this. But if you, as you can see, this stuff is raggedy as hell. Mixing valve, shot to hell. Mixing valve needs to be replaced ASAP. But that's not, I mean, at the end of the day, it's not my stuff. I just run it, and after today, or after tomorrow, I should say, I'll no longer be running it ever again. Nor will I be in this room ever again. So the people who make these decisions can decide ultimately what they want to do with this. But they did make a good decision to switch over to gas. Now let me just run this down with this burner. Okay, so with the D-series burner, we had a what was a sidearm heater or heat exchange right over here. As you can see, this is where the braces or the brackets that held it in place used to be were filed or cut and filed down. So we no longer have that sidearm heater because we're not heating oil. Because we're only burning number 2 oil and we're burning gas, so number 2 oil doesn't need to be heated. It also used to have a, what's the name of the heater? A preheater directly underneath the burner, which you don't see anymore because it's been removed once they took out the old burner. Also, there was a compressor that was right over here. It used to sit right where the ladder is at. It's been taken out. All that shit has been scrapped since. So essentially what we have here is this has a built-in compressor into it. It's a smaller burner. It's a lot quieter. This is the compressor unit right here, this tank. It doesn't have that separate motor where you would hear it in the past in the other video that it had. And there's the oil gauge for the compressor oil. There's your valve for opening up the inlet so you can replenish the compressor oil, and then it goes your pressure gauge right there. Of course, it has been dormant and it's been off for a while because we're not burning on oil, we're burning on gas. So since we're burning on gas, let me just see if I can finish showing everybody the connections for the oil. Okay, so this right here would be your, I think it's an oil metering pump. This device right here, I'm not gonna touch it, it's dirty as hell, so I don't feel like getting my fucking hands dirty. And it supplies the oil into this line here, goes into the solenoid, does what it does over here, another solenoid comes into here, and then you have it goes into your nozzle right over here, and then you have the compressor air that comes in through here. As you can see, that goes down there into that compressor right there. So that pretty much sums that up. So you have your oil line that runs over here. The oil lines are pretty much still the same. They've just been ran a little differently, but the gauge, instead of it being over here, it's now on the other side. So you have your blower motor here. This is your blower motor. With the D-series burner, there was a little hand adjustable screw where you can open this up, disconnect this linkage, which you still can, but I'm not gonna do it. But you pretty much can, once you disconnect the two, you can just swing the burner door open and get a look inside the nozzle and see everything that's inside of there. But of course, you see there's more shit connected here. And the one thing I don't like is the fact that this has multiple, of course, there's another screw there. I guess the last mechanic that opened it up did not put the screw back. This is another reason why I don't fuck with it. I come in here, I take a look, and that's it. And then you have the air manifolds for the fan. And one thing a mechanic told me when I was younger, because when I first started this job, what I was doing was I was running all over the place. I was constantly in the boiler room fixing things. I was constantly doing all kinds of shit. I've replaced sight glasses on these things before. I've done all kinds of shit. The mechanic told me, I remember, I'll never forget, an old white guy. He said, let me tell you something, kid. Let me tell you something. Today's favors become tomorrow's jobs. And it finally started to hit home with me some time ago. Meaning, whatever you do today, you're gonna have to do that from now on. And, you know, that's just gonna be a part of your routine. Today's favors become tomorrow's job, meaning you're not gonna get paid for it. You did it before, so we suppose you could just do it again. That's what he would tell me. But anyhow, this is pretty much the setup of the oil line here. Now I'll run down the gas. So over here we have a booster. This has recently been installed. Actually, when they did the conversion to gas, we got this line that ties in, and the line is about a 3-inch line. Runs all the way up here. That big piece of black pipe, one goes into the vault room, and then the other one goes down here, makes its way down here, makes its way down here, and then you have your gas train. You have your gauges. This is all a bunch of shit. I don't even touch none of this bullshit because once they converted to gas, I'm really not gonna fuck with gas too much. because if you don't know what you're doing, you can cause some shit to explode. So, you know, this is pretty much the rundown of the gas. As the gas train, monthly gas train, makes its way through here. Ball valve, the best valves and the only valves you should be using in your home, by the way, but that's a separate video. And then you have the gas manifold, which is right here. So in order to run the gas, what you're doing here is you're not necessarily pumping the gas into a nozzle like you would do with the oil. The gas runs into this chamber and surrounds this chamber, then it is pushed into the combustion chamber. I'm gonna fire this thing up in a little while, and I'll actually let you see. I don't know if I got a look at it. The sight glass kind of broke back there in the back of that boiler, so we might not be able to get a good look at that. I'm gonna take a look, however, to see if I can find some type of sight glass. Oh, by the way, this is the oil pump, which has been replaced once we went to 2-oil. Of course, it's still got the same strainer, or the same strainer basket, but it has a different mesh strainer that's in there. Of course, it's a lot thinner to make sure that it can capture whatever sediment is in number 2 oil. But since we're not using it, I don't need to open it up. And now the way they revamped this, they revamped this entire setup where they've installed a remote control emergency burner switch by this door, which leads to the outside, and this door, which it doesn't lead to the outside, but it just leads to another room in there. We're not gonna go in there because there's no reason for us to go in there. Ooh, it's kind of scary in there. Now, let me stop. But anyhow, and then they've installed this, this fan. This is something that we never had before. It was just a big louver, which the louver is still there, but they've covered it up with this metal that they welded over it. And they, you know, the city requirements was that we had to put a fan in here. So the fan comes on along with the burner. So whenever the burner kicks on, this fan comes on, and this flap that you see right here, this piece of plastic, that right there pretty much, because the fan blows inside of the room. So when the fan blows, it pushes that, and it pretty much lets the relays know that it's working. If it, for whatever reason, if that stops working, or if the flap stops working, guess what? Your entire operation is shut down. But that's just the way that works. So, with that being said, let me see, is there anything else that I want to show? Walking the back of the boiler. There's been so much damn work done to this boiler. I mean, it's just, it's old as hell. They really need to snatch this shit out, but I mean, it all depends on what they're gonna do. I don't know what they're gonna do with this damn thing. If it was up to me, I'd just tear this whole damn thing out. And they also added this, this temperature sensor, this flue gas sensor. So I guess if there's a backup in the chimney and the exhaust were to come back through this, forgot what it's called, this damper, that's what it's called, a damper. Then that sensor there would pick up on the temperature increase and it would shut down the burner operation, pretty much letting the system know that it is, you know, that there's something wrong. They also installed these pipings on the, what is it, the safety pop-off valves. I think they're supposed to have chains also, but you know, that never was done. But who the hell cares? Anyhow, let me see. What else are we talking about here? One last thing I wanted to mention before I fire this damn thing up. This boiler is what they call a, whoa, I don't know what I know it's a Husky boiler. It's a wide body. You know, most Scotch Marine boilers that you look at inside of a building, they're not this wide. They're not as wide, but they're longer. This one isn't necessarily long. This boiler is really short and wide. As you can see, the girth on it, it's pretty damn wide, but it's not long for shit. A very short piece of machinery. I think they actually did it was a bad choice to put in a short boiler in here. One of the reasons why I say that is because a constant problem that I've had with this boiler is constant leaking tubes. Now, y'all seen the video I did some years back where I had to change leaking or plug leaking tubes. I don't change tubes, what the hell am I talking about? But I plug leaking tubes up here. Normally where the leaking tubes occur is right back here in the back of the boiler. If you open up the door, you normally get a couple of leaking tubes when you first fire this damn thing up. That's the reason why you see the rust and everything on this damn thing. Now, I don't want people saying, man, damn, why does your equipment look so shitty and fucked up? Listen, man, let me tell you something. Years ago, I came in here and I painted the boiler. I had this whole thing nice and black. I repainted this whole damn thing. I wanted it to look good because I figured it was a reflection of my work. But as I painted it up, came in here, I even painted up this dirty ass fucking floor. And I realized how fast it got dirty and how quickly my work went to shit. I said, man, the hell with that. Fuck that. I'm not coming in here painting up nothing. As you can see, the paint peeling, because I painted this as well with nice black paint. I painted this with this blue because it was like a lighter blue color and it had these oil stains all around the front of it. It just shit looked awful. I came in here, I said, I'm going to just go take care of my shit. But like I said, with multiple times a year, especially in the heating season, to deal with leaking tubes, and once you get leaking tubes, all this shit's coming out of your boiler, water all over the fucking place, rust every goddamn where, man. Going through that enough goddamn times, I just said the hell with it. I gave up on it. So I threw in the red damn towel. One thing I did do when they did this conversion though, is I slapped on these ball valves. I slapped these shits on because, like I said, number one, these are the best valves that you can use. And this valve here, I only knew it was a matter of time before that one went bad. Normally what I do when it comes down to bleeding this out, I come in here, in the winter time I'll do it once a week, once a week because it's building up steam. You're collecting rust from the radiators. So I'll come in here usually once on a Friday and hit it like this. Am I doing it the wrong way? I'll leave it partially open so you can see where the water's going. And the water goes into this pit right here. When the sump pump comes in, it takes that water out and disperses it right into the main sewer line. So I'll come in here and I'll do this a couple of times. You can hear that sediment and rust. Now, I don't know why that necessarily is because I never had this problem. I only started experiencing this when they recently changed the entire lower pass of tubes in this boiler. Now, occasionally what I'll do in the wintertime, the same way I described, or pretty much how I demonstrated with my boiler in my place. All right, that's good enough. Boiler plugs right there too. Of course, I don't need them because I don't plug anything in here anyway. But anyhow, in the same case, like what I did in my place, what I'll normally do every now and then is I'll let this thing build up pressure. And as it builds up pressure, then I'll come in here and I'll usually throw it on manual, throw the switch on manual. So it goes up to 5, throw the gauge all the way up. So it goes to 5, and then I'll wait till right when it's around 5 or 4.5 PSI, and I'll come in here and I'll crank up this low water cutoff, and I'll just purge the shit out of it. The same thing I'll do with the main drain valve in the back of the boiler. That way, when you got under the pressure, everything is built up in it. It just force everything out at such a force, it just gets rid of a lot of that nasty shit. One other thing I forgot to mention is with this, ever since they did this configuration, they also made it mandatory that we have to have 2 low water cutoffs. So you've seen the one on the other side, and then you have this one here on this side. One thing that I've been fooled by from time to time is when mechanics will come in here to replace tubes or do welding work, and they drain the boiler out, they fill it back up, and I notice once it's filled back up, the damn thing won't kick on. Look around, try to figure out what the hell is going on, but the reason why it wouldn't kick on is because you gotta come in here and you gotta manually reset this. Once this drops below the water level, you gotta come in here and reset this by pressing one of these buttons. It's usually the red light that'll come on if that happens. There's 2 red lights there, one is not lit. Let me see, if I press it, it should, yep, there you go. For those who wanna know the name of it, this is the name of it. McDonald and Miller. So these are just the rules that the city gave us. And with that being said, just one other thing I want to mention really quickly. It's kind of hot as hell in here. You have your oil and gas switch. Right now we keep it on auto, but if I wanted to go to oil, I can throw this back to oil. When you throw it back to oil, the one thing you're gonna notice is you're gonna have to wait. It has a 2-minute delay before the burner will fire back up. That's just the way they made it. I guess they did it like that for safety purposes or whatever. And the same thing vice versa if you go back to gas. Once you switch from one to the other, it's gonna be a 2-minute delay before it actually comes back in. This is what I've experienced, this is what I've seen, and this is pretty much how it is run. Then, once that happens, once that lays up, it'll come back in. A mechanic showed me something pretty interesting with this relay here. As a matter of fact, I might demonstrate it right now. Let me fire this damn thing up. Okay, so the fan just came in. Fresh air inlet fan is running. You see the flap there is blowing, which means that everything is working according to how it should be. If that would have stopped working, the burner was shut down and someone would have to come in here and figure out what the hell is going on. Booster. This is for the booster. Let's just know that the booster is working. The booster is on automatic, so the booster comes on automatically as the burner comes on. The booster also has a delay. So when the burner shuts off, the booster will probably stay on for at least another 10 minutes before it finally shuts down. I guess they made it like that to keep it from wearing itself out. I don't exactly know how, but that's what they told me. So we're gonna watch this burner fire up. I think it takes this burner about 60 seconds to 2 minutes before it actually initiates a flame. Showed me. So now pretty much what I have it doing is I have it on pilot. Let's see if we can get a look in the back of this damn thing. Now we're not going to see it's too, the glass is fogged up. Yep. But pretty much what I'm doing is I'm holding it on pilot, so the pilot just stays lit and is doing nothing else. That's how you hold it whenever you want to find out what the hell is going on with it, or troubleshoot with it. So now I'm going to put it back to normal setting. The difference with the gas flame versus the oil flame. The oil flame is always a bright yellow, so bright that you normally can't even look directly into it. The gas flame, you can see that this is a blue fire. It's a real mellow, calm blue flame. So this is the burner on high fire. As a matter of fact, I'm gonna throw it on auto for a second. Bring it back down to low fire for a minute. got the how it measures. I think it measures the gas pressure in inches, if I'm not mistaken. There's a certain reading that it uses to measure the gas. I think it's in inches. Let's see if we can get a look. So this is the burner on low fire. We're going to throw it back on high fire again. Side note that I want to mention, when you throw the burner on oil or automatic, like I just did, it doesn't matter what season it is, it's going to always bring the flame up to high fire. In the summertime, it'll just bring it up to high fire if you're only making hot water, and once it reaches the hot water pressure temperature, it'll shut down. In the wintertime, it'll run the flame up until it gets to the desired pressure that your modulator pressure control is set for. That would be this one right here, which I got this one set for 3 psi, so it'll hold it at 3 psi. So it doesn't matter whether you have this on high or low. Once you throw on automatic, it'll automatically override. If you throw it back to manual, wherever you have this set for is where this is going to go. So since I'm going back to manual, it'll bring this down to low fire. For a second, we're going to back up off of it. What we're going to take a look in the back of this boiler. Maybe we can see if the flame in the back of the boiler is blue. This is my heat timer settings. The heat timer is 12:10 a.m. Cutting is at 55 degrees. Temperature outside is 52 degrees. Since we already made a heat cycle earlier, I'm not going to allow it to bring up any steam, especially at this time. They should have their asses in the bed at this time, so I ain't worried about sending up no damn heat. So I will shut this thing back down, throw it to night cycle when it's all said and done. Let's see if we can look at this flame. Alright, you see that flame? That's a blue flame. If I was burning oil, the flame would be a bright yellow. You wouldn't even be able to look directly into it. Maybe with the camcorder, but not with your naked eye. And that's what you call your post-purge cycle. As soon as your flame cuts out, the burner still runs and blows air into the chamber. That's to pretty much purge out any unburned gases that might have remained inside of the combustion chamber. And pretty much this is a safety feature that they've set up so there's no explosion inside of that combustion chamber, basically rupturing the inside of your boiler or completely destroying your building depending on how much gas might be in there. So we're not going to stay and run this heat cycle. The one thing I don't like about this heat timer is when you system at 128, no, 129. Oh, yeah, they started bringing up steam. They better not get happy because they're not getting no heat. So once you throw it on manual or you bypass it, if the temperature is below the set point, it's gonna automatically just round it off to a heat cycle. So the way I'm gonna override this, since it's nighttime anyway, we're gonna go into settings. Or no, I'm just gonna go into shift it to night, done. No call for heat. The call for heat at night is, well, I gotta wait for this thing. I think it's at 39 degrees or I think it's 40 degrees, but we're not sending up heat anyway. So I'm gonna throw this burner back on. And once again, like I said, the booster still runs a few minutes after you done shut, or after the boiler shuts off, the booster will still run. Throw this back on. In the on setting, everything is shut down, and I'll show the before we head out. Okay, so we're done with this here. Not gonna stay in here. So like I said, this is, once again, it's not a long boiler. It's really short. And the reason why I don't like short boilers is because the flame is so big with these burners that it'll shoot all the way. Let me just turn this light on for a second. It won't take much effort for the flame to make its way all the way to the back of the boiler. You never want the flame to reach all the way at the back of the boiler. And the way it's set up, as short as it is, that means it's not going to be able to withstand the same amount of heat as a long boiler will be able to withstand, because it has more length and distance. And I also believe that longer boilers are just simply more efficient because it takes longer for the heat to pass through the boiler before it actually exits. Remember, this is a 3-pass boiler. You got your combustion chamber, which goes all the way to the back. You have your lower row of tubes, which pretty much runs right alongside of your combustion chamber, brings it back to the front, to this, where this door is at. And then you have your upper level of tubes, which bring it all the way to the back to the smoke bonnet, which is this device right here, into your smokestack, and out to your exhaust chimney. So the longer the boiler is, and that's how you pretty much sustain heat and make a boiler more efficient, is by having that length, having it, as long as it can extract as much heat out of that flame as possible. That's what makes your boiler more efficient. If your boiler can't extract heat from a flame, then it's not efficient at all. The efficiency on the boiler is rated off of how much heat it can hold in through the jacket, which is this right here, how much heat loss it has, and how much heat it can gather out of the flame. Now, when it comes down to Scotch marine boilers, which this is a Scotch marine boiler, they are very efficient as far as extraction of heat, but it's considering the way its design is built, it loses heat over here. It can lose heat through these doors. Through the sides of it, not really, but mainly through the front and through the doors, a lot of heat can be lost through there. So we're pretty much done with this here. I just show the vault room one time before we go. And this right there is the gas meter. The gas meter that was installed from the time the gas burner was put in here. So this is pretty much what runs, what tells Con Edison what's happening. And then you have it come from here, and it runs right from the street right into here. This is the vault. Of course, none of this stuff is a super or your average plumber supposed to mess with. That's what Con Edison deals with. So we are essentially done. Oh, one last thing I'll show you. Of course, this is the remote control switch on the outside of the boiler room, but you pull it up and down and shut it on and off. And then the heat sensor that replaces that pressure troll. It was originally on the return line, this one right here, but I since then remounted it up here because I believe you get more of an accurate reading for this return line. Actually, that's not a return line, that's a steam main that branches off into a riser and makes its way upstairs. All right, this video is finished and concluded. This is my last video I'll be doing on this boiler.